Yes, welcome to another video for chapter 6 or section 1. So this one we are going to talk about one fund theorem. So we have already discussed about the feasible sets of risky assets, and we have also discussed about the efficient frontier, and we also discussed about Markovitz's model as well as its problem, and then we solve it using two fund theorem. In one fund theorem is, so you are trying to see what will happen when you buy one fund, one mutual fund plus a risk-free asset. So what will happen to your feasible set, and also how will the new efficient frontier look like when you are only considering one fund, one mutual fund, and a risk-free asset. So previously we have seen that this is going to be the feasible set of your risky assets. So this will be the feasible set of your risky assets, right? And we have also discussed that this line on top here is going to be your so it's going to be your efficient frontier. Now when you add a risk-free asset, let's just say maybe this risk-free asset is here, risk-free asset is here. So this is what you can get, and then you look at one mutual fund. So let's say maybe your fund is somewhere here, right? So how will the new feasible set look like? The feasible set between these two is gonna look like this. It's gonna look like a straight line which passes here, right? So this is gonna be your feasible set. So this is gonna be your feasible set, right? So like wherever the asset lies, so that will be your feasible set, right? Your feasible set. So it's gonna be a straight line because the correlation coefficient of risk-free asset and the mutual fund is going to be 0, right? So it's just going to be a straight line. So we know that we can keep on increasing this thing to a point where it touches the tangent. So to a point where it touches this graph at a tangent, at a tangent, right? So we can call this portfolio here a tangent portfolio. We can just call this a tangent portfolio. We can call it a tangent portfolio. In other books, they say that you are maximizing your Sharpe ratio. So to maximize this angle of inclination, to maximize it, it means that you will have to find your tangent portfolio, right? And then we're gonna say that you have maximized your Sharpe ratio, maximizing your Sharpe ratio. So anyway, how do we do this, right? So as we can see from our newly developed set, we can see that our new feasible set is going to be somewhere in between. It's going to be here. So this will be your new feasible set. So this is going to be your new feasible set. So this is going to be your feasible set. And this line on top is going to be your new efficient frontier. So when that line is going to be your new efficient frontier, so you are trying to find that line by finding this asset, by finding the asset over here, or this portfolio over here. You are trying to find this portfolio. We're going to call it the tangent portfolio, as we have already said, where this thing is going to meet at a tangent, where they will touch at a tangent. So anyway, how do we do this? We know that to find the tangent, it's going to be tan theta. It's going to be your, again, so we said this is going to be your risk, it's going to be your returns, this side. So you're going to find the returns of your portfolio, tangent portfolio. We can say TP minus the returns of our risk-free rate. So it's going to be risk-free rate, our risk-free rate, over the risk of our portfolio. So yeah, the risk of our tangent portfolio minus the risk-free rate, again minus the risk of a risk-free rate. But then we know that the risk-free rate has no risk, so it has no variance. And then you're going to solve this. Now, when you solve this, right, you're going to have a long mathematics. And then at the end, what you'll have, you're going to have the returns of the asset. I'm going to zoom in to make it look better. So you're going to have the returns of the asset minus risk-free equals to the sum of the weight. So you're going to use G. So you're going to use V sigma I J. And then you're going to solve this. I mean, like for all. So you're going to say for all your i's, right? And then your answer is going to look like this. So you're going to have your sigma 1 1 up to sigma 1n, all the way to sigma n1, all the way to sigma nn, multiply by your weight, v1 up to vn. All this thing equals to what? All this equals to returns of 1 minus risk-free rate, all the way to the returns of n minus risk-free rate. And then you again, so this is particularly ax equals to b. You reduce the rows of a to find your weight, your v's over here. And then when you find them, they will be not normalized, they will be unnormalized. And then you are going to normalize them, as we have previously shown. You're going to say let mu 0 is going to be equals to the sum. So you can just say v. Let v0 equals to the sum of all vi's, vj's. And to find a normalized weight, you're going to say the weight of I is going to be equals to this weight v over v0. So this will, so basically what you have found here is the weight of individual assets that will be on the tangent portfolio. That will be on the tangent portfolio. So you have actually found this portfolio. You have found this portfolio. These weights are for this portfolio, basically. So this is how you find your tangent portfolio. If they ask you to find the tangent portfolio, this is what they want you to find, right? So you are trying to find a portfolio that is going to be tangent with the risk-free line, and that line is going to be your efficient frontier. So anyway, we are going to discuss capital asset pricing model in the future. We are going to discuss factor models. We are going to discuss utility and portfolio choice, risk measures, stochastic interest rate, stochastic dominance, and efficient market hypothesis, as well as behavioral finance. So this will be the end of our section 1, or in your book is called chapter 1. So thank you. So if you have any question, you can ask me in the group, or you can write it in the comments below. So anyway, thank you.